Okay, so you asked about asymptotes of exponential functions. So once you see this, I think you'll see it's not too hard. So let's say you have 2 to the x minus 3 plus 5, okay? When you graph that, I would make an XY chart, and I tell my students to look and see what number is going to make the exponent 0. So that would be 3. So 3 minus 3 is 0. 2 to the 0 power is 1. 1 plus 5 is 6. So when you plug in 3, you get 6. So then I tell them, plot some points on either side. So I'm going to pick a 4 and I'm going to pick a 2. So 4 minus 3 is 1. 2 to the first power is 2. 2 plus 5 is 7. If I plug in 2, 2 minus 3 is negative 1. 2 to the negative 1 is 1/2. 1/2 plus 5 is 5.5. Okay? If you would continue doing that, if you would plug in a 1 and a 0, you would see that you would get 5 and a 4th and 5 and an 8th and so on. So what's going to happen is it's going to level off here at 5. It's never going to go below 5 because this, the lowest it can get is close to 0. It'll never get to 0, but it can get really close to 0. And so your lowest number for y is going to be 0 plus 5. So that means this number out here is your asymptote. Everything on the right-hand side of 3 is going to get really steep. Okay? It's going to, it's going to go through there. It's going to be really, really steep. Everything on the left side of 3 is going to level off, but it's going to level off toward 5, toward y equals 5. So this number out on the end is your asymptote. So if you would have y equals 7 to the x minus 3, this is your asymptote. So 1, 2, 3, you draw a dotted line, and you would have something that would look like this. It would be really steep, and it would level off. And I'm not going to bother plotting points and getting really specific here because your question was about the asymptotes. If you want to know exactly where this crossed the y-axis and where things happened, you could plot some points, do an XY chart like this. But it's going to have an asymptote at y equals negative 3 because this thing will go to 0 when you plug in really, really small numbers, or it'll get really close to 0. Okay, so that's how you find the asymptote. That's pretty easy. Okay, then you asked about the domain. So if you have log base 3, let's say, of x plus 5. The domain of this is just, well, what x's can I plug in there? Well, you can't take the log of a negative number. You also can't take the log of 0 because this equation, when you take the log of something, you're asking what exponent you need to get to a certain number. So if I take log base 3 of 9, the answer is 2 because it takes taking 3 to the second power to get 9. Log base 3 of 1 is 0 because 3 to the 0 is 1. Log base 3 of 27 is 3 because 3 to the third is 27. But if I try to do log base 3 of negative 4, I get an error if I type it in my calculator because I can't take 3 to any power. There's no power that exists that will give me negative 4. 3 to any power will not give me a negative number. Same with 0. I can't take the log of 0. I'm going to get an error. It doesn't exist. So you're looking for what numbers make that bigger than 0. So you just write that down. X plus 5 is bigger than 0. Not greater than or equal to, because it can't be equal to 0. It's got to be bigger than 0. It can be 0.000001, but it can't be 0. So then you just move that over, so x has just got to be greater than negative 5. So that's your domain. You could write it like that, or you could write negative 5 comma infinity. Okay? So if I had y equals log base 7 of 2x minus 4. You just take what's in here, 2x minus 4, set it greater than 0. So that means 2x would be greater than 4, x would be greater than 2, and so you could say that, or you could say 2 to infinity with the parentheses. Now, it gets more complicated when the stuff in here is more complicated. If I have y is equal to log base 5 of x squared minus 4. Okay, now you've got a quadratic, and that makes it more complicated. The easiest way for me to understand this is to picture what the graph looks like. The graph of x squared minus 4 is a parabola that goes down 4, and it looks like this. And so I know it's going to cross there at 2 and at -2. Okay? So, well, where is that positive? Well, it's positive here, because literally it's above 0 there and there. Everywhere in between -2 and 2, I get a negative number. Like if I would plug in 1 squared minus 4 is negative. If I plug in 2 squared is 4 minus 4 is 0. If I plug in 0 minus 4 is -4. So in order for this thing to be positive, x has either got to be bigger than 2, like 2.5. 2.5 squared minus 4 is going to be positive. Negative 2.5 squared minus 4 is also going to be positive. So the domain for this one would be -infinity to -2, union +2 to +infinity. Okay, so hopefully that helps. If you still have questions, email me and let me know.